So we've got a capacitor that is being charged. This means that current is flowing through the wires, and when you have current flowing, that means that a magnetic field is induced. The first part of this problem is just asking us to find the magnitude of that magnetic field 10 centimeters away from the center of the plates. Now, because the problem is specifically asking for us to analyze a point on the outside of the capacitor, then the details of the capacitor itself, like its capacitance and the diameter of the plates, those details end up being irrelevant because really we can just use the same formula that we would use when trying to find the magnetic field from just outside any wire. So recall that the equation for the magnetic field induced by a long wire is equal to the magnetic constant, mu naught, multiplied by the current flowing through the wire, divided by 2 pi, multiplied by the radial distance away from the wire that we're looking at. And honestly, with the values we're given, this is a pretty simple plug and chug problem. Recall that the magnetic constant is about 10 to the power of negative 7 Tesla meters per ampere, but you multiply by the current, and the current is given to us, so we're told the rate of charge, 32 millicoulombs per second, but remember that 1 coulomb per second is just the same thing as an amp, so it's 32 milliamps. So that's 32 times 10 to the power of negative 3 amps, all divided by 2 pi, multiplied by the radial distance away, which is given as 10 centimeters from the center, so that's 0.1 meters. If you put that into a calculator, then we find the magnetic field strength to be 6.40 times 10 to the power of negative 8 teslas. So that is the magnetic field as the capacitor is being charged. But the problem also asks us to find the magnetic field strength after the capacitor is fully charged. So we can use the same equation, but just remember that when a capacitor is charged, fully charged, that means that there's no longer current flowing through the wire. So if the current is 0, then if we look at our magnetic field equation, we can see that that makes the entire equation 0. So there is 0 magnetic field in the case where the capacitor is fully charged. And that is it for this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. If you have a request or a question, leave a comment down below, and I hope you all have a lovely day. Bye-bye.